By optimizing, you're going to get programs that run in the least amount of time possible, but yet safely, making sure that you don't have machining problems in your program, such as things that cause chatter in the corners, might cause too much stress on the tool. All of that is gone, goes away. Your tool's cut properly, which gives you extended tool life as well. You can tell what's happening by seeing the graph activity here, and I'll explain more about that in a minute. So once we get this thing optimized, we'll walk through some of the tools, show you what the software is telling you, and how it's going to save so much money. Let's do a little deeper dive into the results that we see here. You'll see a panel here that popped up that talks about your optimization savings. You can put a couple of numbers in there and find out exactly what you saved on this particular part, how many parts, how often do you run them, and the numbers that you see down there can be quite large. But that's not the interesting part for me. I'm going to look at the analytics right here and show you how that works. But to give you a taste, I'm just going to click through here with the numbers that are in here. So 100 parts in this case. We're going to go ahead and calculate savings for that. So there's 16,000 for that. I have 5 machines. I run a couple of shifts. So in a year, what happens? There's $1.1 million in saving. Just this kind of cutting. This is one of those things, the more you use it, the more savings you make. Now I'll show you some of the interesting things for the guys that do metal cutting, the programmers that use this. All of these graphs, and there's tons of graphs available, we're only looking at 2 of them right now. One is chip thickness, because that's very important in machining. The more constant the chip thickness is, the better your material removal is going to be, and the better parts you're going to get. Now, obviously when you program this, CAD systems are pretty good at laying out toolpath. Sometimes some are better than others, depending on your operations. Let's take a look at what we got here. I'm going to hide the optimized program. So now we're looking at the original NC program. Let's pick one tool. So what you'd want to see for optimal chip cutting in machining is that you're hitting a certain peak almost all the time. You can see right here there's some unevenness. Now what you don't know is what should it be. The programmer should have known that. The CAD system does a pretty good job in some cases, not such a great job in other cases. This is where the optimization is really going to help you. It's going to even that out for you. Now I'm going to do a quick switch for you. I'm going to take away the original program and show you just the optimized program. You see the difference? Now you've got that target being hit almost all the time, including when you're going on and off the part. So it's going to take your original cuts and feed rates, subdivide them into much smaller things to work with, and change the feed rates automatically for you to hit your target all the time, every time, with every NC programmer that uses this. They all become expert machinists. Now I'll show you another one. We'll compare the 2 together. This gets really interesting. We'll zoom in a little bit, and here's where you see the difference between the original NC program, the optimized NC program, and that bright green is the money that's being made for you when you're doing the Vericut optimization. It's showing you the difference. That's all on the plus side. What happens if you overprogram the tool even a little bit or a few times? You know, in the shop, that typically equates to broken tools, damage or chatter on the part. So let's look at a different tool. You see the red color? Right away that alerts you that there's something different, something wrong there. The red color means that from the original NC program feed rate, optimization needed to slow things down in order to better survive that particular cut. So we'll zoom in a little bit on that, and here's what happened. Based on our force values that we had for optimizing, there were certain limits in place, and there are other limits in place. You might not see them all here, but one of those limits said, nope, we can't go that fast, we need to slow things down. That caused the forces to drop, which saved the tool. That caused the chip thickness to drop a little bit. That's not ideal, but we had to in this case in order to save the tool. So what you're getting with this optimization is the fastest possible NC program, the best savings you can get, and the safest cutting. It covers you on all bases all the time. So this is just a quick review of what happened when we just went there, clicked one button and said optimize this. That's Vericut Optimizer.